Hello everyone, this is example 1 on section 2.2. Here is the function f of x is equal to x squared plus 6x plus 5. And what do we want to do? We want to do all of this that I have written here to the side, and I'm going to add one more thing, which is sketch the graph. What I want you to do is find all the information you need in order for you to make a sketch of this graph. The first thing we need to do is determine if it opens up or down. And how do I know that? Well, I have to look at A. That's what I look at. What is A? A is the coefficient in front of your x squared term. So when there's nothing written in this place here, that means A is equal to 1. And let's just go on and find B. B is the coefficient in front of the x term. So B is 6. And let's find C. C is your constant term, which is positive 5. How do I know if it opens up or down? By looking at A. If A is greater than 0, that means if it's a positive number, then it opens up. That means when I sketch my graph, the parabola is going to look like a U shape. If A is less than 0, then that means that the parabola opens down. And it will look like this, like a sad frown. So since our A is equal to 1, that means A is positive. I know that the parabola opens up. So I'm done with number 1. Number 2, find the vertex. Here's step 1. We're going to go to step 2. Find the vertex. To find the vertex, since this function is written in standard form, we call this the standard form. To find the vertex can be found by finding the x-coordinate of the position of the vertex on the coordinate plane and the y-coordinate. I'm going to look for the x-coordinate first. To find the x-coordinate, I use this formula, the opposite of b over 2 times a. And then I plug in the values that I found here. The opposite of b is 6, so the opposite of b is negative 6 over 2 times a, and a is equal to 1. So 2 times 1, and that will equal negative 6 over 2, which is equal to negative 3. So far, for my vertex, I have found the x-coordinate of my vertex. I need to find the y-coordinate. To find the y-coordinate, you take your x-coordinate that you just found, and you plug it into the original function, which is right here. So I take f of x, the original function, x squared plus 6x plus 5, and I evaluate it when x is equal to negative 3, which is the x-coordinate of your vertex. I plug in negative 3 anywhere there's an x. And then I evaluate. Negative 3 squared is 9, plus 6 times negative 3 is negative 18, plus 5. That will equal 9 plus negative 18 is negative 9, and negative 9 plus 5 is equal to negative 4. This value that you just evaluated, that is your y-coordinate for your vertex. So your vertex is at this location. Negative 3, negative 4. You found your vertex. Number 2 is done. Number 3, I'm going to do it right here. Find intercept. This should say find y-intercept. That's the one I'm interested in right now. The y-intercept. When your function is written in standard form, Finding the y-intercept is very, very easy. All you have to do is look at the value for c. c is equal to 5. That means that your y-intercept is at 0, 5. And this number is always the same as your constant when you have standard form. Number 3, done. To find domain and range, let's sketch the graph first so that we can see what the domain and range is. So I have all this information. Vertex is -3, -4. Y-intercept is 0, 5. And the graph opens up. So let's try and graph this. Here is my graph. We're going to plot the vertex. We said the vertex was at -3, -4. So 1, 2, 3, -3, -4 would be 4 down. 1, 2, 3, 4. Here is the vertex. We also said that the parabola opens up. And we also found that the y-intercept is at 0, 5. So let's plot that too. Here's 0, 1, 2, 3, 4, 5. Here's 0, 5. That means that this parabola will open upwards like this. It will crash the y-axis at the y-intercept and continue. And this will open up this way. And I'm sorry about the squiggly lines, but it's not easy drawing on this drawing pad. You get the idea. So this would be a sketch of your graph. Now let's look at domain. When we talk about domain, we're talking about all of the valid x values that work for this function. Now these arrows here that I drew at the end of this parabola, that means that this parabola is going to keep growing and growing and growing upwards forever and ever. So that tells me that all of the x values on this x-axis are valid values for this function. How do I write that? We write it using set notation. We say that all x's such that x belongs to the real numbers. That means that all the x's on this x-axis are part of the domain. For the range, using set notation, I write all y's such that y, and then I look at my y values. I start at the bottom. The first y value I hit is -4. This is -4. That's the first y value that my function has. And then it continues to have all of these y values all the way up, all the way to where? To infinity. So I will have all y values that are greater than or equal to -4. That is the range. And there is the answer to all the things that I asked for. I hope you understood, and I'll give you a second example on sketching a quadratic function. I'll see you in the next video.